Okay, guys, so here is F-13. So we're going to find the indicated derivative. So the very first step is you've just got to figure out, like, what gets the prime after it. So if they're asking you to find dc dd, okay, another way of writing this is, it's c prime of d. So we're going to do, so I guess we'll do c prime after c. All right. Oh, another way I've said it before is that this is implying that, c is that c equals c of d. That's what I wanted to say. Okay. All right, so that means that c is equal to c of d. So this is the part, this is called implicit differentiation. And I'm not really sure why they call it that, but it makes sense to me thinking of it like this, this is pretty sound logic. If they're asking you to find dc over dd, all right, here we have neither variable is solved for. C is not solved for, D is not solved for. So it's really unclear which is the input variable and which is the output variable. But they're asking to find dc dd, which means in prime notation c prime of d, which implies that c is actually c of d. So c is dependent on d. So that means that you're going to need a c prime after c because c prime is the derivative of the inside. So whenever you're taking the derivative of a c part, you're actually using chain rule on that. Okay, and I won't explain that anymore unless anyone wants me to, but that's why it's called implicit differentiation, I think, is because this is what is implied here. This is what is implicit within the larger scenario. Okay, so we're finding the derivative. So let me go like this. So 3cd sine of blank, all right? So, so I'm going to take the derivative. To take the derivative of this one, I've got to first do the derivative of the inside. And for that, I'm going to need product rule. I've noticed a lot of you doing this, like you're putting a line to separate the functions, and I really like it, so I'm going to use it. And I need a c prime after a c derivative. So this is going to be, so the regular derivative of 3c is 3, but I need a c prime after. The d comes down, plus 3c comes down. Derivative of d is 1, okay? I'm putting parentheses around that because that's the derivative of this inside function. The derivative of the outside function is cosine of blank, but what goes back in the blank is what used to be in there to begin with. So 3cd is going back in there. Equals normal derivative, there is 2d. Okay, so now I've got to solve for c prime. Couple ways you could do this, I guess. Like you could distribute the cosine inside, but I'm going to just divide both sides by it first, I guess. So, so I can get 3c prime d plus 3c equals 2d over cosine of 3cd. Okay, and then I will subtract the 3c from both sides. And let me just save room. So I get 3c prime d equals, and this is just algebra, over cosine of 3cd minus 3c. And then I'm going to divide that whole thing by 3d. All right. So, and remember, c prime is the same as dc over dd. So I'll say, at this point, I'll switch to Leibniz notation, but you don't really need to if you don't want to. 3cd minus 3c over 3d. And guys, we last year in pre-calc, this is called a complex fraction because there's we would simplify something like this, last year. So you can if you want to, but this is a perfectly fine answer. My answer might be simplified a little bit more than this. Like I may have gotten common denominators up here and then did keep, change, flip or something, or I might have just done keep, change, flip. So my answer might have, instead of the 3D down there, I might have multiplied the top by 1 over 3D. You know, so that might have been where I got my answer, but that's okay. This is fine. All right, now we're going to do this one. Now this is atypical, sort of, and you'll see why in a moment. Okay, so dx over dy. If they're asking us to find that, they are implying that x equals x of y. And the reason this is atypical is because usually you see that y is the function, you know, and x is the input, like y is the output and x is the input. But here it's different. X is the output and y is the input. So that could happen. So since this is the situation, we need an x prime after x. So you're just going to really have to concentrate because past phases, you're used to putting a y prime after a y when you have x's and y's. And now we need an x prime after an x. So I'm going to need chain rule to take this derivative. So the inside is y to the third plus 2x squared blank to the fifth. All right. So the derivative of this inside, remember y's are normal, but we need an x prime after an x. So the normal derivative of 3y to the third is 3y squared plus 4x x prime. Make sure you get parentheses around the derivative of the inside always. And then the derivative of the outside is 5 blank to the fourth. And then what goes back in here is what used to be in there, which is y to the third plus 2x squared equals, okay, the derivative of x, normal derivative is 1, but we need an x prime after x, an x derivative, so that's going to be x prime. Okay, so here is the thing. We need to get, the algebra here is a little bit, you know, involved. We've got to get the x terms on the same side, all right? So we've got this x term here and we've got that x term there. We need for them to be on the same side. And then the non-x terms to be on the other side. So guys, I do think it's probably, there's a couple ways to handle this, but we could distribute this into that parentheses. I think that's what I want to do. So distributing this inside the parentheses, I end up with 15y squared, y to the third plus 2x squared to the fourth plus 20x x prime. Okay, that's just some algebra right there. Okay, so I just distributed that to each of those terms. So now I need these to be on the same side so that I can factor out the x prime. So I'm going to subtract this one from both sides to get it over there. And then I will also subtract this one from both sides to get it over here. So I end up with 20x x prime minus x prime equals negative 15 y squared. Okay, now I can take, so both of these terms, this is a single term, that is a single term, and I can take the x prime out. When I take the x prime out, I've got 20x, y to the third, 2x squared to the fourth, minus 1. That's negative 15 squared, y to the third. All right, so let's make this page 1 of 2. so that we can continue on the other side. Okay, continued on the back. All right, so continued on the back. So really my last step, guys, I'm just going to divide both sides by the parentheses. So I'm going to have dx dy equals, and then that will be the answer. So I don't have to keep flipping back and forth. Let me just write it here. All right, so we're going to have, it's blurry. All right, so dx dy, right, it's normally backwards. All over. And I was talking to Mr. Crockett in class, and because I thought like at college they might want you to simplify things more, and he said that he even at BU would tell his students not to simplify their answer, you know, unless it's advantageous. If simplifying an answer, if there's like a multi-part problem and simplifying a derivative would allow them to do something next in an easier way, then simplify. But I guess even at the college level, they're saying not to simplify answers. I mean, there's really not much we could do here anyway, but I just wanted to mention that because I just talked to him today about it. All right, guys, there it is.